Hey guys, welcome back to my channel Success Engineering. Today we are going to see how to estimate the heat load calculation using E20 sheet Excel program. So you can see here I have this E20 sheet Excel program. So to estimate the heat load calculation we need drawing, U value as well as Excel program sheet. So let's start now. So I would like to request you guys, before I start this video, please would like to request you to please like, share and comment my video, and don't forget to subscribe and hit the bell icon so that you can get the notification of my upcoming video. So let's start now. I have one drawing and we have to calculate the heat load, and we'll compare this load with the HAP report which we have estimated in my previous video. You can see here I have estimated this in my previous video office building. Open this. We'll compare this and go to the system. You can see here, open the report. You can see here this if you go to this space load, you can see the master bedroom 1 we have estimated 38.6 MBH and airflow is 1881 CFM. So we'll compare this E20 estimation load with this HAP report. So we'll see how much is the difference between both. I think yesterday I have calculating the another one, OMB building. So let's open that one, OMB building. Open. You can see a living room. Yes, living room. So go to the system and generate the report. You can see here this living room 1 is 12.3 MBH and airflow is 601 CFM. So let's start now and we'll compare the report with the HAP. So open the drawing. Open the AutoCAD file. I have open the drawing which we have done yesterday. Also open the U value sheet. This is the U value. It is taking time little bit. So you can see here the living room 1 I have calculated yesterday for this room with HAP software, hourly analysis program software. Today we are going to calculate with E20 the same room, and we will compare the report and we'll see how much is the difference between these two. So let's start now. We have this sheet. So first of all you have to fill here the details. The detail is OMB building, project name, location is Dubai, Client is Success Engineering, consultant is Tiva, and estimation date is 9/11/21. So first of all, you should fill this basic detail. Floor is ground floor. Basic detail you should fill ground floor. Space is living room. You can see here the space name is living room 20/18. Living room 1. Area in square feet. Just calculate 20/18. 360 square feet. 360 square feet, and ceiling height is 13 feet. So here automatically this volume I found here in the cubic feet 4680. Now fill the weather details. So you can see here, go to this HAP software. You can go to this weather and just open this weather report. You can see here summer dry bulb temperature is 107 and summer wet bulb temperature is 75. Simply put it here 107, wet bulb is 75, and room temperature is 76 degree. Comfort, this human 76 degree is nothing but the human comfort temperature for the room, and humidity is 50% generally considering. So we know these two values. So third value and these two value you have to calculate from the psychometric chart. So open psychometric chart and simply plot these two value. I have this software. If you do not have software, you can directly find this value on the psychometric chart. So how to find, I will show you manually first of all. So 107, you can see this horizontal axis 105. So 106, 107 is here. Simply go up and check this wet bulb temperature is 75. So simply check the wet bulb temperature. You can see this curved line is humidity representing, and this vertical line is representing dry bulb, and this line is wet bulb. You see this line showing wet bulb. So simply go to this 107 and found the wet bulb temperature is 75. So simply go up, and here is 70. You can see 70, 71. So 71, 72, 73, 74, 75. 75 is here, and this point is near to this 20. So here will be the 22. And if you go this side, you can see here this humidity ratio is sorry, near to 0.11. So if you want, if you plot simply here, just click here and at the point type here 0.1. Simply type here known value 107 dry bulb, and the wet bulb is 75, and simply click apply and go to the psychometric chart. You can see this is near to 20% humidity, and this is the dry bulb temperature 107. You can see here dry bulb is wet bulb is 74 and RH is 21, and humidity ratio is 75. this line representing what? This line representing humidity ratio, and this line representing wet bulb temperature. So you can move vertical to this line 107 triangle, and you see here this line is 60 and this is 70, so it is near to 75, and also this one wet bulb is almost 74. So simply put here, you can say RH is 21.2, so simply put here 21. Humidity ratio is nothing but 75, simply put 75. Again plot this point, dry bulb temperature 76 and RH is 50%. So simply go here, dry bulb temperature 76 and RH is 50%. Simply click apply, so you can see humidity ratio is 62.67.2 and wet bulb is 73. Wet bulb is 63. So simply type here 63 and this one is 72. Now you will get the difference here. 67. Sorry, here is 67. You will get the difference. So this minus this. You will get the difference. Okay. Now BP, this bypass factor is 0.12. 0.12 and contact factor is 1 minus bypass factor. CFM per person is, you can go to this, click close this and go to the space living room. You can see here the bedroom living room is CFM per person 5 and CFM per square feet 0.06. So simply type here CFM per person, CFM per person 5, and here is CFM per square feet 0.06 and number of people is 2. So you will get this value. Now go to this room sensible heat, solar gain. That means this radiation load from the glass. So radiation load is nothing but the load coming from the window due to sunlight. So you will check here the orientation north and west. So simply here north, this window size, you can see this 6 feet by 4 feet. So this the radiation load is coming through this wall. 6 feet by 4 feet area, 6 feet by 4 feet, the total area, net area for this window. So here is, you can put 24, and then west side is again same, west glass is same again 24, and then U value of the glass is, you can see here the U value of the glass. Skylight, go to this window schedule, you can find here 0.588. Simply type here 0.588, temperature difference. For the temperature difference, you should go to this carrier handbook. Estimation load part 1. You should go here. Solar heat gain through the glass, ordinary glass. So for the Dubai, the latitude is 30 degree north. Solar heat gain through ordinary glass. So you can find that the peak load month. So peak load month is July and May. You can find here north and west side. You can see this north and sun time is 4 o'clock. So because this heat is maximum heat is at 2 o'clock is the peak time, but heat is transferring, it will take a little bit time, so maximum heat will transfer within 2 hours. So generally we are considering at 4. So north elevation and the sun time is 4 o'clock. You are getting this value 14. So simply put here delta T is 14, and this one west side, go to the west side. You can see this west exposure, sun time is 4 o'clock, so it will be 164. Simply put here 164. Okay. Now solar and transmission gained, wall and root, that means this conduction as well as radiation heat transfer. So conduction and radiation, transmission load. For this one, you should go to this, first of all check this exposure wall. Exposure is north and west for this room, for this space. So north wall, generally in the E20 we are providing this net wall area, not gross wall area. So net wall area is 18 by 13 for this west side, 18 by 13 height. So total is 234 minus 24 is the window area. Just subtract. So you will get this net area of this exposure, west exposure wall, 210. So simply type here west exposure, sorry, north exposure. So simply type here how much, 210 net area, and then west exposure 20 by 13, 20 by 13, 260 minus 24. So you are getting 236 is the net area for this west wall. 236, and simply type the U value, put the U value. For the U value you should open this U value Excel sheet, U value Excel sheet. You can see the external wall section, the U value is 0.089. So simply type here 0.089, that means 0.089. Here also will be the same. And what will be the temperature difference? Temperature difference is nothing but the temperature equivalent temperature plus correction factor. So find the equivalent temperature. You should go to this talking about this table number table. This complete book is given here. This complete career design book. I think it will be up. Let's find that table. Just look for that table. So, where is that one? I think it will be here. Yes, it's here. This equivalent temperature difference for dark color sunlight and shaded wall. This is for the wall, and correction factor is, see, the correction to the equivalent temperature. Table 20a, and here is table 19 for the wall. So check this exposure. The north wall exposure is, you should look for the north wall. So here is the north shade, and sun time is 4 o'clock. Building weight is 100 pounds. So simply look in this row. At 4 p.m. is the 4, and just add this correction factor. Correction factor, you can see this outdoor design for the month at 3 p.m. minus room temperature. So outdoor design for the month is 107, minus room temperature is 76. So 31, and the daily range, you can see the daily range here. Go to this space, you simply open, and you can see this summer daily range 17.5. So 17.5 is nothing but you look for this 18, and 31 look for the 35. Just check in the higher side. So you are getting 21. So 21 plus 4, 21 is the equivalent temperature plus correction. 21 is the correction factor plus 4 is the equivalent temperature. So total you are getting 25. So simply put here 25. And now look for the west side. So for the west side, this is the west side, and building weight is 100 pounds. Sun time is 3 p.m. So you are getting 10. Okay, then correction factor will be 21 only. So total 10 plus 21, it will be 31. Simply put here 31. Okay. Now transmission gain except wall and roof. That means this all glass. Heat load due to the glass, all glass. Transmission gain. So simply all glass. So if you go to this, if you look for this space, there is 2 window. Just add that area. So 24 into 2, you are getting 48 square feet. So simply all glass is 48. The temperature is nothing but the outside minus inside. So outside will be 107 and inside will be 76. So it will be 31. Okay, and the U value for the glass is 0.59, 0.59. Partition. Look for the partition. If you check here, this is the partition wall. So 12 feet by 13 feet. 12 by 13. Your area will be 156 square feet. So simply type here 156, and partition, this temperature difference will be outside temperature minus inside temperature minus 5 degree less. 107 minus 76 minus 5 degree, it will be less. So 26. So 26, and partition U value. Go to this U value table and look for the partition. You can see here 0.40. You simply type 0.401. Okay. Now ceiling, there is no ceiling partition, and floor will be, so here roof will be the same as floor. So floor area will be 360. So your roof also 360. There is no ceiling and floor partition, so leave this much only. Okay, and your floor U value will be, look for the floor, 0.375. So U value 0.375 for the floor, and floor temperature difference, that nothing but the equivalent temperature plus correction factor. So you can see here the equivalent temperature difference for dark colors and light and shaded roof. So look for this exposed to the sun. Exposed to the sun, and building weight will be 80 pounds per square feet. Sun time will be 4 p.m. so it will be 32, plus correction factor is nothing but the same. So 32 plus 21. 32 plus 21, it will be 53. We type here 53, and then here this infiltration and bypass here. So leave this one, and internal heat, number of people will be 2, and BTU per hour, that means this sensible heat. If you go to the go to this space and open this living room, you can see here internal, this 2 people medium work, the sensible heat is 295, and lighting is generally considering 1.2. If you see here, 1.4 watt per square feet. So 1.4, type here total area 360, and here will be 1.4 watt per square feet, and equipment load is 1, change to watt, so 400 watt. Okay, simply type here 500. Okay, and now this latent load will be number of people 2, and BTU per hour per person is, but open this space, go to this internal, you can see here the latent load is 455 BTU per hour per person. Simply type here 455, and then what will be the next step? So this equipment will be, you put 2, number of equal to lighting is 360, latent load is 455. Just verify once again. Skylight is no. To exposure. To exposure, and here in the solar and transmission gain to exposure and roof area. And then transmission load all glasses and the temperature difference and the U value. Partition is also same. No ceiling and floor partitions, so leave as it is. And then infiltration. We type here 5 CFM. And internal load, that is nothing but the sensible load, 360 watt. .4 watt. Here only 1.4 watt. Okay, and then I think it's done. So just compare this value with the report from the HAP. You calculate it, go to the system and simply open the HAP report. You can check here. The living room is 12.3 MBH. So 12.3 into 1 MBH is nothing but the 1000 BTU per hour divided by 12,000. You can see here the 1 ton only. And just open this Excel. You are getting 1.9. This only one. Here is 1.2. So here you are getting how much? 1 ton. And here is little bit high. That means this HAP software is the accurate, and in the E20 is a little bit more. So 2 ton, 1 ton or 0.5 ton is acceptable. So this is coming 1.8, and in the HAP is 1 ton. CFM is 1060 CFM, and if you see this HAP, so here CFM is living room 601. Okay, and if you see this total MBH, .7 MBH. So, and in the HAP you are getting 12.3 MBH. This HAP is accurate actually, but here is giving an approximate value. It will not match almost it is same. So I hope guys you learn from this video, and if you learn from this video, so please don't forget to subscribe and share my video, and don't forget to subscribe my channel. Guys, you should always watch my full video, so you learn something regarding this heating and cooling load calculation. And I will put this link for the another video which I have uploaded related to this HVAC. I will put the link on the description of this video. So please keep watch. If you still not watch my previous video, so please watch my previous video, so you will learn how to calculate the heat load calculation with HAP and with E20. enjoy this video, so I will stop here. We will meet in the next video. So thank you for watching my video. Thank you. Bye bye.